let's look at question 11, the one with the graph. I'm going to just sketch this so I've got an idea of what's happening. I've got this curve here with a tangent line there. Okay, not a perfect sketch, but it's okay. This is the point A, k minus k squared. I am also told that f of x is minus x squared. I recognise that shape, so that's okay. Oh, let me just lock the focus. There we go. Hopefully that will stop the bouncing around. And let's go. Let's look at the questions. A part 1. It asks me to write down f dashed x. Well, I can do that. F dashed of x is minus 2x. Part 2. Find the gradient of L1 in terms of k. Well, I know that if A is on the curve, then at that point, the gradient of the tangent is equal to the gradient of the curve. So at A, I know that x is equal to k. Therefore, gradient of L1 is equal to minus 2. Instead of x, I've got k. So that's minus 2k. So I know the gradient of L1 is that. Moving on to B. Gives me now that B, this point here, has got coordinates 1, 0. That point B. And it asks me then to show that k equals 2. Well, I've now got more information about the gradient of this line. I know that the gradient of L1 is also going to be, let's just jot these coordinates down, A is k minus k squared and B is 1, 0. So the gradient of that line is the difference in the y, so minus k squared minus 0 over the difference in the x's, over k minus 1. So I've got the gradient of L1 being this from before. I've also got the gradient of L1 being this now. So therefore, I know that minus k squared on k minus 1 is equal to minus 2k. And this is going to lead me to the value of k. So now it's just a case of solving this equation. Let's multiply by k minus 1. Minus k squared is minus 2k times k minus 1. That's minus 2k squared plus 2k minus k squared on here. Let's bring everything over here. I've got add 2k squared, so that's k squared minus 2k is 0. How do I solve these? K in both terms, factor out the k. K minus 2 is 0. So I know that k is 0, which is not applicable in our situation, or k is 2, and that's the answer that we were required as required. So that's part B, done. Let's move on to C. I'm going to do another sketch, particularly of the part that I'm interested in, which now is this part of the curve over here. So I had the tangent from before, so let's get that in there. That's the point 1. I know that k is 2 now, so this becomes the point 2 minus 4. And I'm also, this is L1, I'm also interested in this line here, L2. So I've got that diagram to help me understand what's going on. Let's have a look at the question. Find the region of R, which, given in the question, is this shaded area here. So I've got the area between a curve and a line or another curve. I can work out quite quickly the equation of this straight line because I know that it passes through 0. I know that for 2 across it's come 4 down, so it must have a gradient of minus 2. So I know that L2 is y is minus 2x. So to find this area in here, I can come along quite nicely and say, okay, area is going to be the integral between the limits of 2 and 0 of the top curve minus the bottom curve with respect to x. And let's put these in, 2 and 0. Top curve was the minus x squared. The bottom curve I've just worked out was minus 2x with respect to x. Got a lot of minus signs flying around in there, which I don't like. So I'm going to rewrite this as plus 2x minus x squared with respect to x. And now I can do this integration. Square brackets, integrate 2x, increase the power, divide by the power, so that's just 1, minus, increase the power, divide by the new power, there we go, between 2 and 0. Let's stick in 2, that's 4, minus a third of 2 cubed, that's 8 thirds, minus, stick in 0, I get 0 on both. So I've got 4 minus 8 thirds. That turns out to be 12 thirds minus 8 thirds is 4 thirds. So there's my answer for C. D, let's come back to the diagram. D now starts to ask me about an area S, which it says is the area enclosed by the line L1, the x-axis, and the graph of F. So S is this area in here, which I'm going to need to know to get the ratio of the areas. Now, of course, I could set about doing an integration for that, but I can also realise that the area of S is going to be this triangle minus the area that you've just found. And with this, I'll hopefully be able to get this done quite quickly. This area of the triangle, base is 1, and the height is 4, so that's going to be a half times 1 times 4. This area I just worked out was 4 thirds, so let's work this out. That's 2 minus 4 thirds, which is equal to 2 thirds. So I've got the information I need. Therefore, the ratio of the question asks me R to S. I know that R from before was 4 thirds to 2 thirds, which is then a ratio of 2 to 1. And I've done